tuning in. Welcome for another lesson. Here we will be discussing what power is. What power is, after which I'll say something about machines. So, power is the rate of doing work. Power is the rate of doing so. So, whereas energy is the ability to do work, power is the rate of doing work. So, you can have energy, but if you cannot convert it to work, then you are powerless. So, power is the rate of doing work. Power is the rate of doing work. The rate of doing work. This means power equals to work per unit time. Work divided by time. Work divided by time. The SI unit of work is what we call the watt, abbreviated capital W, the watt. And this means 1 watt is equal to, because work is in joules and time is in seconds, then equals to 1 joule per second. So 1 joule per second equals to 1 watt. 1 watt. So from this definition of work, of power, we can also say that power equals to work divided by time, which means work is in force times distance according to the definition of work. Then we divide this with time. So we have another aspect coming in of distance out of time. And we know very well that distance out of time gives us what we call speed. Therefore, we can see that power equals to force times uniform speed. Force times uniform speed, because this is distance over time. That is distance over time. Therefore, power can also be given by force times speed. This example can make us understand more. Given a person weighing, me rub here so that I may wait. A person weighing 500 newtons takes 4 seconds. Takes 4 seconds to climb upstairs to a height of 3 meters. What is the average power in the climb? What is the power of this person? What is the power of this person? We have said that power is the rate of doing work. So work out of time. And the work will be given by force times distance. Then we divide now by time, which means we take 500 newtons times 3. Then we divide by 4 seconds. This happens in 4 seconds. Therefore, work will be given by 500 divided by 4 times 3, which is 375. 375 watts. We could have also alternatively, we could have also calculated speed, which is distance out of time. Therefore, 0.75 meters per second is the speed. Now with speed, we can say that power equals to force times speed. Force times speed, or velocity, uniform velocity, which will be a force of 500 times 0.75, which will automatically give us 375 watts again. 375 watts. So whenever we talk about power, we simply mean the rate of doing work, and this is given by work per unit time. I want to bring about something called machines. Something called machines. Machines. Something called machines, which is the final bit in this topic. We know that machines, or simply a machine, is a device which makes work easy or efficient. When we work with machines, work becomes easier or more efficient. Machines are many. We have levers, we have pulleys, we have gears, and a lot of other machines which are all used for one purpose, and this is to make work easier. Therefore, I would like to bring forth a few terms which are associated with machines before we see some calculations. Therefore, these terms used under machines, one of them is effort. An effort, abbreviated E, is the force applied to the machine, which is in newtons, of course. In newtons, so force is in newtons. So the force applied on a machine, we call it effort. If you have a wheelbarrow, the force you will cause on it is called effort. If you apply an effort, the machine creates some force, and that is called load. Abbreviated capital letter L. This is the force exerted by the machine. Force exerted by the machine, and of course in newtons. Then the other term, number 3, the other term we call it mechanical advantage. Mechanical advantage, abbreviated MA. The mechanical advantage of a machine is the ratio of the load to the effort. The ratio of the load to the effort. Since it's a ratio, mechanical advantage will have no units. Mechanical advantage will have no units. So the mechanical advantage of a machine is given as the ratio of the load to the effort in the machine. Since there are two forces, we don't expect what we call units. We can have what we call effort distance. Effort distance, abbreviated capital D, the E, and this is the force, or this is the distance through which the effort moves. So the effort you apply, the distance it goes through, we call it effort distance in newtons, in meters or meter, small letter m. Therefore, meter is the SI unit of effort distance. The load distance again, number 5, load distance distance through which the load moves. Through which the load moves. So the distance through which the load moves is called the load distance. So these are a few terms. We are going to increase the terms. There is another term called velocity ratio, and I have to clean here so that you may understand what velocity ratio is. Velocity ratio of a machine, VR, is the ratio of the effort distance to the load distance. So as we had said, mechanical advantage is load out of effort. Then we have velocity ratio being the distance of the effort out of the distance of the load. This is something we are supposed to master. Want to bring about the last term used under machines. The last term used under machines before we look at specific machines. Therefore, the last term will be efficiency. The efficiency of a machine. The efficiency of a machine. Therefore, what we call efficiency is abbreviated is the ratio of the work output to the work input expressed as a percentage, which is expressed as a percentage, which is expressed as a percentage. So we can talk of, work output. Work output is the work done on the load. After exerting your effort, what work gets done on the effort, on the load? That work which will be done on the load is what we call the work output, which means work done on the load is the load times the load distance. The load times the load distance. We have work input. Work input is the work done by the effort. Work done by the effort is what we call the work input in a machine. Therefore, work input will be the effort multiplied by the distance moved by the effort. Now coming to the definition of efficiency, the ratio of work output to the work input in a machine expressed as a percentage, then we will say that efficiency is given by work output, load, times the distance moved by the load, out of effort, times the distance moved by the effort. But we know that load out of effort, okay, multiplied by 100%. But we know that load over effort is mechanical advantage. Therefore, we can say this is mechanical advantage of a machine multiplied by distance of the load over distance of the effort. Again, this translates to, since we said that velocity ratio is given by distance of the effort out of distance of the load. Then we can see it has been in the change. Now we have distance of load over distance of effort. So this means that distance of the load out of distance of the effort gives us the reciprocal of velocity ratio. Gives us the reciprocal of velocity ratio. And with that now, we can say dL out of dE is the reciprocal of velocity ratio. Therefore, we can say that the efficiency of a machine is given by mechanical advantage divided by velocity ratio, because here now we are multiplying with 1 over V, so it becomes velocity ratio in the denominator multiplied by 100. Then we call it percent, multiplied by 100%. Therefore, the efficiency of a machine is given by mechanical advantage divided by velocity ratio times 100%. Thank you very much for following. We can meet in a later example so that you may see how we work out these things. Subscribe to Shifting Grades.